Welcome students to the chapter of vectors. This module is very much important. In this we are learning multiplication of vector and more about we are learning of dot product and properties of dot product. Now the multiplication of vectors can be done in two ways. One is dot product and one is cross product. Now what is dot product? Dot product, another name is scalar product. But what it is? Let's see. Vector dot vector gives you scalar. Yes, you understood very clearly that here the multiplication symbol is been given by dot. That's why the name dot product. And the answer which we get is scalar, a number. That's why the another name for this is scalar product. Yes, here we get answer as a real number. Now, the another type of multiplication is cross product. The name of cross product is also called as vector product. Here, vector cross vector gives you vector. Now what here it is happening is the multiplication symbol is denoted by cross. That's why the name is cross product, and the resultant I get is vector. That's why the name is vector product. Yes, in my resultant I will be having magnitude also and direction also. Let us see deeply in dot product. Let's give the definition of dot product. If A bar, B bar are two vectors and theta is an angle between them, and theta is between 0 and pi, including 0, excluding pi. Yes, you can see in the diagram, OA bar, A bar, OB bar, B bar, theta angle between them. Then A bar dot B bar is magnitude of A bar into magnitude of B bar cos theta. Yes, you can write also as AB cos theta. And this AB cos theta is nothing but scalar, a real number. Yes, here A and B are magnitude of A bar and B bar, so they will be always positive or 0. So they will be always greater than or equal to 0. Now let us take one small example. I give you A bar and B bar. Magnitude of A bar is 3, magnitude of B bar is 2, and angle between them is pi by 3. So what is A bar dot B bar? A bar dot B bar, AB cos theta, AB cos pi by 3. A value 3, B value 2, cos pi by 3 value half. 2 get cancelled, your resultant is 3. Yes, your resultant is scalar. Now let us come to property of dot product. The first property says if theta is acute, means theta is in the first quadrant. If theta is in the first quadrant, cos theta is positive. If cos theta is positive, cos theta is greater than 0. If cos theta is greater than 0, AB cos theta is greater than 0. If AB cos theta is greater than 0, A bar dot B bar greater than 0. You are very correct. Whenever your theta is acute, your dot product is always positive. If your theta was obtuse, your theta was in the second quadrant, so cos theta was negative. Cos theta was less than 0. The AB cos theta was less than 0. Therefore, A bar dot B bar was less than 0. You are very correct. Whenever your theta is obtuse, your dot product is negative. But what if my theta is pi by 2? If my theta is pi by 2, my cos theta is cos pi by 2, which is equal to 0. My AB cos theta is 0. My A bar dot B bar is equal to 0. And from here, a very important result comes out. Whenever your dot product is equal to 0, your theta is pi by 2 and your A bar and B bar are mutually perpendicular, and vice versa is also true. Remember students, dot product 0, vectors mutually perpendicular. Vectors mutually perpendicular, dot product equal to 0. One more result is obtained from here, that A bar dot B bar equal to 0 can happen for three cases. First, either A bar will be null vector, B bar will be null vector. Remember, null vector cannot be drawn since its magnitude is 0. In both the case, null vector is always perpendicular to any vector. Now, here the third case is theta is equal to pi by 2. In all the three cases, we are getting A bar mutually perpendicular to B bar. Let us come to the next property. The property says if A bar and B bar are parallel, the theta between them is 0. So cos theta is cos 0, it's equal to 1. So the answer A bar dot B bar is AB cos theta, AB cos 0, AB into 1, AB. From here, one more result has come. The A bar itself is parallel to itself. So A bar dot A bar is mod A bar into cos 0 because they are parallel to each other. So A bar square is equal to mod A bar square. So A bar square is equal to A square. A very important result. Vector square is equal to magnitude square. Remember students, vector square is equal to magnitude square. There is another property coming called as commutative law. Yes, you do A bar dot B bar or B bar dot A bar, you will get the same scalar, same answer. Another property is distributive law. There are two types of distributive law: left distributive law, right distributive law. In left distributive law, you can see A bar is been multiplied from left. It's just like opening the bracket. A bar dot B bar plus C bar is A bar dot B bar plus A bar dot C bar, and B bar plus C bar dot A bar, B bar dot A bar plus C bar dot A bar. Thank you.